Hello everyone, good morning and good evening. So we'll start the session, guys. Let me share my screen. Just a minute. Okay, so good. So today, what we are going to do is we are going to discuss about the task implementation. So in the previous session, we discussed about the time travel, right? So when it is coming to the task, right? So here in Snowflake, the task we can able to perform multiple things. General meaning of what it mean by the task. If you are doing something, we will call it as a task. Let's say if you are inserting the data into the table, if you are creating a table, everything will be a task, right? But here the Snowflake task, what it is going to do is mainly we can able to assign to specific warehouse, virtual warehouse. This is nothing but computation layer. So exactly which virtual warehouse it has to run. So the task has to run. So we are going to decide. So for example, here, whatever that virtual warehouse we have here, we can able to see only one virtual warehouse. But when you are working in a project, right, you may see more than one virtual warehouse. More than one virtual warehouse, you can able to see the in the task. So in this particular situation, so when you are implementing this, so here, let's say, for example, data loading activities every day, specific time we can assign to development virtual warehouse task. For example, anyone implementing streams or anyone is performing, let's say we're going forward, we will see all these things. Anyone is performing specific insert for the specific time period, we can assign to specific virtual warehouse. Based on our requirement, we can assign to multiple virtual warehouses like developer virtual warehouse, testers virtual warehouse, load virtual warehouse. Based on that is nothing but a capacity. This is related to computation. Okay, so going forward, we will see how to create multiple virtual warehouses here. One thing in a task is we can decide which virtual warehouse, what is the capacity you can able to use it. When you are running a query, what is the capacity you need to assign to your virtual warehouse. This is nothing but a computation that we can decide when you are executing a task based on the task. Task is nothing but what you are going to execute, nothing but it can be a select statement, it can be a copy statement, whatever it may be, you are going to give under a task. This is first thing. Second thing is we can able to schedule for specific time period. Scheduling also possible within a task. That is another thing. Based on your thing, you can able to schedule. But one more thing is when you are giving the task schedule, always you need to give schedule time in the form of minutes. Minutes only you have to give schedule time. That is the one thing. And if you want specific day, specific week, specific month, yes, we can able to do that. That is with the help of cron syntax. Cron job syntax, we can able to implement it. We will see that. Along with this, assigning to the specific computation, assigning the task to specific schedule, what we can do is we can able to assign this particular task. With the help of task, we can manage dependencies. For example, task 1 has to complete. Once the task 1 completed, then only task 2 has to run. These kind of dependencies we can able to create it in a task within a Snowflake. This is nothing but kind of scheduling. So kind of like a triggering for specific time period. We can able to do it with the help of task implementation. Now here, okay, one more thing we need to understand. This is just for the interview question, but no one will use this. Within a account means our Snowflake account. This is our account, right? Within a account, including all users together, you can create 1000 tasks within our Snowflake account, not more than that. 1000 tasks we can able to create within a Snowflake account. Okay. And another thing is, when we are working with this, every parent task can have 100 child tasks. It means this is direct 100 direct child tasks, not more than that. It means, let me show you the diagram, then we will understand clearly. Task thing, but let's observe this one. See this one, what you observed here. We can able to see this is a root task. Root task means where the task is starting, that is nothing but a parent task. This is nothing but root task. Now, within this particular task, we can see two child tasks. Task B, task C, both are the child tasks. Task A is a parent. At the same time, task A is starting from here. So we will call this as a root task. When it is coming to the task B and task C, these both are child for task A. Now again, task B is a parent for D, E, F. For these child tasks, task B is a parent, task B, task A is a parent. Now, task B, it is connected to three child tasks directly, right? Like this, you cannot give direct child task more than 100. That is a restriction, but we won't use it just for the interview purpose. Remember it. Within a account, we can create 1000 tasks all together, including parent and child. But one more condition here is, when you are having a child task, right? See this one, task F is a child for task B. Again, if you have like to connect this task F to from the task B as a task C as a parent, not possible. It means task B and task C both cannot have a child as a task F. That is not possible. It will not allow. Every child has single parent here. Only one parent only. Every child task can have only one parent. That's it. We cannot go beyond that. And every parent task can have 100 child task directly. Clear? Like this, we can able to create a tasks. Now, one more thing here, when it is coming to these tasks, right? So when we are implementing this, so we need to perform based on, it's up to us, like a dependency. Based on the dependency, we can create a multiple tasks. So task A is, task D is dependent on task B. Task B is dependent on task A. If the task A completes, then only task B has to complete. Task B completes, then only task D will start. This kind of dependency we can manage. Let's see so how we can able to work with this task and then how to implement it. Then we will get one clear idea here. Now to implement this, what we will do is we'll create some sample tables. So based on that, we will try to work with a task. Now let's come here. What we are going to do is I will create some table here. When I am creating a table, observe this one. I'm creating table here, sample table, employee table I am creating, employee ID. And one more thing, when you observe here, see this integer, auto increment, start with 1, increment by 1. Because when you are inserting the data into the employee table, if you don't give any values, by default, it is going to increment, start with 1, increment by, this is one of the sequence generation within Snowflake. We can able to create a sequence generate for the employee ID. Every time when you insert the data into this table, it is going to increment by, first it will be 1, next it will be 1 plus 1 2, next it will be 1 plus 2 3, like that the increment will happen. And here we are giving order. Order means if I don't give this, right, this increment will not be in a sequence. That's why we are giving order here. And at the same time, See this employee name. So here employee name, we are giving default value as Snow. It means when you don't insert any values to the employee name, default every time it will be taken as a, for example, I will give Snowflake. This value will be inserted as a employee name every time it will be a Snowflake when you are inserting, because it's a default value. If I don't insert any value, every row when it is inserting, it will take a employee name, and we are having load time. This we are given as a date data type. Now when you create this table, now the table is available. Okay, let me change it to public schema. We will do it in public schema. Now we created a table, and let's come to this table, and then employee, right? This is the employee, and you can see ID, name, and then load time. We can see these three columns in the table. Our requirement is I want to insert the data into this employee table every minute. Select star from. If you see the data in the table, you won't have any data. So just now the table is created. For this particular table, our requirement is we want to insert the data into this table. We need to insert the data into this table every 1 minute. That is our requirement. If I want to insert the data into this table, what I have to do? Generally, I will run a insert command. Now observe this one. Just for the example, we are taking insert into this particular table. I am inserting load time column. For the load time column, I am inserting the value called current timestamp. When I use current timestamp value, what will happen? The time will be loaded, current timestamp will be loaded to this particular load time. Now let's execute this. If I execute this, what will happen to the employee ID and then employee name? Employee ID, it will be auto incremented. Employee name will be Snowflake every time. See this? First time I have inserted manually. If you check the data here, I can see this is the data, right? Employee ID, name, and then load time. Okay, this is fine. But again, after 1 minute, I wanted to insert the data again. Then what I have to do? Again, I will execute the statement. Then if you see the data in the table, you can see two rows, right? Again, one more time, I wanted to insert the data into the table. Observe this one. One more time, I'm trying to insert. Let's say every minute I wanted to insert the data into the table. This is our requirement, guys. Let's assume that. For example, we are discussing this. Now, what we can see, we have three rows, and then employee name is this one, and then you can see the load time. We can see this information. Okay. Now, here I don't wanted to do it manually. Here manually I am running whenever I wanted to load the data into this table, right? I wanted to go with a schedule. Don't want to trigger this manually, coming here and then coming and then running this one, right? It has to schedule, it has to run automatically. If you wanted to do that, within a Snowflake, we have a scheduling capability, and then we can manage dependency capability. Let's see that what we are going to do is, if you wanted to do this, we can create a task. When you are working with a task, observe this, what we are going to do. This is the syntax of the task creation. Create task. This is a task name. This is task name. And warehouse, compute warehouse. And schedule 1 minute. We are assigning this task to run in this particular virtual warehouse. That is nothing but a capacity of the computation. And we are giving schedule in the form of minutes. We are specifying 1 minute schedule. It means every 1 minute, this task has to run in this particular virtual warehouse. When this task is running, what it is going to do? This is the statement what it is going to run for every 1 minute. Now, so this one as we have given it is a as, and then we are giving insert into the table, right? And then so we can able to see the load time, and then we can see the values, and then we can see the current timestamp, right? So observe this one. When I execute this, what will happen now? See this one, task successfully created, right? Task has been successfully created. Now remember this, once you created a task will not run direct. It will be by default, it will be in a suspended state. It will be in a suspended state. It means we have given a task, we given a schedule, means it is not going to run default. It is not going to be active. It will not be in an active state when you created a task. Remember this. What we need to do is we need to resume the task. If you observe show tasks, see this. This is the task name, and then observe this one. What is the virtual warehouse it is assigned? What is the schedule time we assigned? 1 minute. Predecessors. Predecessors means nothing but a dependencies. We will see that in the coming. Predecessors is nothing but dependencies. Here we don't have dependencies. If the task is not having any dependency, right, that we will call it as a standalone task. Standalone task. And observe the what is the status of the task? Status of the task is suspended, right? Status is suspended. And at the same time, if you observe the definition, what the task is going to do, see this one, insert into table. This particular column, we are inserting the values. See this one, current timestamp value, we are inserting into this particular table. That is the definition of the task. But what is the status of the task now? Suspended. If the task is suspended state, it will not execute this for every 1 minute. The task has to be in active state. So that is nothing but we need to give this task into, we need to set this task to the resume state. For that, what you need to do is alter, we have to give task name, alter task. What is the task name here? This is the task name, alter task name, and then we have to give resume. See this one. When you give this command, this task will come to the schedule. Observe this one. Now we have resumed this one. Now observe the show task. Previously, when you see the data, how many rows we have here in the table? 3, right? Now let's see after some time. Now observe the show tasks. What you can able to see here, see this task scheduled for 1 minute. And what is the status of the task now? Status of the task is started, right? Previously, what is the status of the task? Previously, the status of the task is it is in a suspended state, right? Now, what is the status of task? Task status is started now, right? Now, every 1 minute until you stop this task, it will keep on loading the data into this our snow this particular table, which you have given it in a sorry. What is the table? This is the table. This particular table, every 1 minute, it will try to keep on loading the data into this table by default until you stop. So here that is a scheduling, right? Here, if you see this, let me, previously we have 3 rows, right? Now observe how many we have, 4. After 1 minute, what will happen? Again, it will load one more row into this particular table. After 1 minute, so because we have given in the form of minutes, right? Always you need to give in the form of minutes only. We cannot go beyond this. Less than this, if you wanted to go, you need to try with a cron job implementation. We will see the syntax for that. Now here we specified this. Now it is going to run every 1 minute. Every 1 minute when it is running, it is going to load the data to this particular table, what we have given within the task statement. This is the execution, what the task is going to do here. Here we don't have any dependency. So this task will be a standalone task. If you have any dependency of a task, then that will call it as a dependency task. Now here we created only one task. And based on this task, what we will do is we will see in the next parent and child relationship task. Now, when you are running a child, parent should have a data into that. Then only we can run the task. Now here, one more thing. Let's execute this. Let me check how many rows we have now. Let's see how many we have now. 5. See this one. After 1 minute, we received one more row, right? After 1 minute, again, what will happen? One more row will be inserted into this table, right? So like this, so we can work with a task. And one more thing here, when we are working with this, here, if you wanted to stop a task, then what you need to do is we need to set this alter task name to resume to suspended. Suspended we have to give. If you give suspended, what will happen is the task will come out of the schedule. The task, once it is created, the task will be there in your objects, right? The task will be there. See this one, we created a task. The task you can able to see that here also. See this one, task. This is the task what we have created, and it is at every 1 minute it will execute. What is the status now? That is a started, right? The task will be there, but if you do suspend, it will not be in an active state. That's it. Whenever you want, you can able to bring this to the active state. So you don't want to schedule it, you can able to suspend it. Now let me suspend this. Now I have suspended. Just a minute. Suspend. Sorry. Suspend. Okay. Now see this one. Task is suspended. Now observe the status of the task now. What you can see. Suspended. Task status is suspended. So we have to resume. Once the task is created, then it will go to the schedule. Whenever you don't want it to, so keep it in a schedule, what we can do, so we can suspend this. We can suspend this. That is a like how we can able to stop the task. Okay, this is one thing. Now, so how to handle dependency, how to create dependency of the task here. So when you are working with a task, how we can able to set up a dependencies. Now let's see how we can able to do that. Now let me come here. What we will do is we will have a tree of tasks. So within the task we can able to perform. Let me create the parent and child tables here. So based on that, we will try to implement it. Now we will take parent table, parent task, same like a statement we are going to execute it here. Say this just the table name I have changed it to the parent table, and remaining is same. See this one, start with an auto increment by 1, and then we can give. So here we have given this. When we are creating a table, what we have given? We have given an order, right? We have to give this, otherwise it will not keep it in a sequence. So we'll give order. Now this is the parent table. We created a, sorry, let me create a parent table. Now we have a parent table. Now let's create a parent task. Parent task, what we are doing is we are inserting the data into this table for every 1 minute by using this particular virtual warehouse. Same thing, we are using current timestamp to this particular load time. Same thing, we created a parent task. Now we have parent table, we have a parent task. Now parent task, what will happen? In parent task, the data will, when you run that parent task, the data will be inserted into this particular table, parent table, right? Once we have the data in the parent table, now our requirement is, let's assume our Snowflake has to pick the data from the parent table. It has to insert into other table. It has to insert into other table. That is a requirement. It has to pick the data and it has to be inserted into other table. So if you wanted to do that, now let's observe this one. What you will do is we will create a child table. We will pick the data from parent. We will insert the data into the child. Now to implement that, now we have a parent task. Let's create a child task also. When you are creating a child task, let's create a child task. We are creating two tasks. If you wanted to practice more than like one child task, yes, you can do it. Now let's create child table. Now observe the child table. We simply creating the employee ID, name, and then load time. We are not giving any increment by, we are not giving any default value here. Now let's execute this, right? And let's observe this one. When you are creating a task name, this is the warehouse, and see this. Here in the above task, what we have given, we given the schedule time as 1 minute. Observe this one. In the parent task, we given the schedule as 1 minute. In the child task, what you are going to do? See this one. We are giving, instead of schedule, we are specifying after parent task. After parent task we specified. It means it is going to come execute once your parent task is completed successfully, then only your this task, your child task is going to execute. See this one. We are specifying this task when when this child task is going to run, when the parent task is completed, after successfully completion of the parent task. Why we need to give the dependency on the parent task? Observe the statement here, what we are going to do it in a task. What this statement is doing, we are inserting the data into this child table. We are inserting the data, these columns, from where? From parent table. See this one. From the parent table we are picking the data, and then we are loading the data into this table. It means if you have a data in the parent table, then only you can able to load the data to the child table, right? Otherwise you will not get the data into the child table, right? So this child is dependent on this child, right? Child 1, let's see, child is dependent on parent. Until you get the data to the parent table, you won't get the data to the child, because child data is picked from parent table. Now we are creating a child task. Now observe this one, because it is dependent on parent one. Now the task, parent task, child task, both are created. Now let's see. If you observe show tasks, observe the show tasks, what you observed. See this one, we have a child task, we have a parent task. Now if we let's come to this, you can see both are in a suspended state by default. And what you are going to do it in a task, you can see the definition, right? And at the same time you can see, observe this one, predecessors. This is a schedule, I mean this is a dependency, this is a child task. Child task is not having any schedule time. See this one, this is a parent task is having a schedule time for 1 minute, but when it is coming to the child task, there is no schedule time, right? And along with that, if you observe it here, see this one, so you can see like this one, predecessors, this is related to dependency, right? So if the task is having dependency, so then we can see that predecessors here. Now when you are running parent and child task, what you need to do, from the suspended to we bring this to the active state, started state, right? For that, what we are going to do, we have to give the command alter task name, right? Let's bring this here, alter task name. This is for the parent task. The same way for the child task also we need to do, right? Now let's observe, this is for, what is the child task name? This is a child task. This is a child task. The same way we have to suspend also, right? So this is suspend. Now observe this, sorry. Observe this one. Now one is parent task, one is child task. Now we wanted to resume it. When you are resuming and when you are suspending, when the task is having any dependencies, right? In this particular situation, always remember when you are running a task, you need to run your child task first instead of parent task. That is a order. First, you need to run child task based on the dependency. You have to take care of it, and then second, you are going to run your parent task. This is the first. Generally, so we will think about parent task has to run first. No, because child is depending on a parent. So first child has to run, then parent has to run. Otherwise, if you start a parent first, later if you try to start a child, it will not pick, because child will not understand from where it has to start if the parent is started. That's why first we will start the child. Child will keep on waiting for the parent to complete. Once it is completed, parent is completed, then the child immediately it will start. So when you are suspending also, you need to suspend parent first in a reverse order. You need to suspend child next. When you are running, remember this, you need to run child first, then parent. When you are stopping, you need to stop the parent first, then you need to stop the child next. This is the order. So to understand this, remember the like parents and children's concepts. Let's assume like when you are offering a food, the let's assume the friend's family came to house with along with the children's are very small, let's assume that. So we always the parents will take care of the children's. The two, like when they are having something snacks, let's assume that first we need to start with children's, parents will help them, right? So both, let's assume both are having. Once their children's are started, who has to finish first? Parent has to finish first to help their children's, right? Same concept, you can assume that to easily remember. When you are running, first you need to run a child first, then you need to run a parent next. When you are stopping, first you need to stop the parent first, then you need to stop the children first. Otherwise, the dependency will not be managed properly. So let's assume that I am doing parent first. If I start parent first, what will happen? Observe this one. I started parent first and later I am running a child next. See this? Unable to upgrade the root graph. Task is not suspended because if the parent task is in suspended state, then only the child task will run. Now let me suspend the parent task. Now the parent task is suspended, right? Until unless the parent task is, if it is running, child task will not trigger. That's the reason first you need to, based on the dependency, so you need to run the child task first, then you need to run the dependency task next. Now we are trying to run the child task first. Observe this one, child task. We ran the child task. Now the child task is started. Now I am running the parent task. Now what it will do? Child will keep on waiting for parent to finish. Now parent task is started. When the parent task is completed, what will happen? The data will come to the parent table. Once we receive the data into the parent table, immediately what the child is going to do? It will pick all the data from the parent table. It will insert the data to the child table, right? Every time, every 1 minute, it will pick all the whatever the data is. Just for the example, we are doing this like normally we won't pick all the data. It will be mostly, it will be incremental manner. We will see that scenario in the coming sessions. Now here, every all the data we are picking, and then we are loading into the child table, right? Every time we are picking all the data, we are loading into the child table. Now observe this one here. Now let's see the data in the parent. Later we will see the data in the child. So now here one row is there, right? In the parent table, what child will do? Immediately if you run the child task also executed, then you can able to see the child task data also. Now after 1 minute, this parent table will have how many rows? Will have two rows, 1 and 2. Once the parent task is completed, this first row, second row, both, it will pick. Again it will load the data to the child table, so that again 1 and 2 it will be available in the child, because we are the statement we have given like this. Every time, every 1 minute, it will pick all the data from the parent, and then we can able to see that in the particular the child table. Now when you are running this schedule, where I can able to see all the schedules things, where I can able to see the task executions. Generally, when you are running any statement like copy command, when you are running, where you can able to see that, you can see that in a query history, right? The same way, when you come here, let me come to the monitoring. See this, you can see task history. See this one, you can able to see the task history. But if you try to see the query history, you can see only the select statement, but you cannot able to see whether the task is running or not, right? Only the select statement, alter statement, you can able to see what you have executed, what you have created here. But execution things, we cannot able to see it here, right? So if you wanted to see those things, the task, you can able to see that in a task history. See this task history. You can see, observe this one. You can able to see that, right? Refresh it, you will get task history. So what is the task? It is succeeded just now, and then how many previous runs we can able to see that, and then you can able to see that the task information, right? See this one, schedule, and then you can able to see the what is the like a task it is running in the backend. So you can able to see these things. So here, if you, okay, this is related to the documentation. One more thing is, when I come to data, when we come to the objects, come to the public, where the task is created, here I created a task. When I click on this, you can able to see the graph, the lineage. This we will call it as a lineage diagram. It means which objects it is depending on. So what is the data flow, how the data is flowing from one object to another object. This we will call it as a lineage diagram. You can able to see that here. This is the recently added feature. You can able to see the lineage diagram in the task. Before that, we can, before version, like we don't have this task history, we cannot able to see the task history here. At the same time, lineage diagram also is not available. But in recent, recently, so it has been updated, you can able to see the lineage diagram also here. See this one, for example, if I see the parent, see the graph, you can able to see that, right? The what, from where the task is connecting to the parent, right? So the next child, right? So like this, you can able to see the diagram, and then you can see the run history also. So what is happening in the backend, so what is running, right? The details of the task, so how the task is created, right? So you can see all these things, so here in this particular task implementation. And when it is coming to this, one more thing, if you come here and then check the data now, you can see the data. Now let's see the data in the parent first, and every time it will pick the data, and then how many times it has been loaded? 5 times. The same 5 times, every time it will pick. First time it will pick one, next time it will pick these two, next time it will pick these three. Like that, it will load 5 times into the child table. Now let's see the data in the child table. You can see the data in the child table now. See this child table data, right? This is the last execution it has loaded. Before that, it had picked this one and it has loaded. Before that, it picked these three and it loaded. Second time, this is the first time, right? Every time it is picking all the data and then it is loading the data into the table. You can able to see the data. until we stop. This task is going to run. Let's say this is a simple example I will give you. So to when we are going to use this kind of things. Now, our requirement is we need to calculate a tax calculation for the employees. Whenever the employee salary is been updated or employee salary is inserted into the main salary table, then only we can calculate a tax, right? First, the data has to be loaded to the salary into the employee table. Then based on the salary, once it is loaded, we can calculate a tax, right? This is a dependency. First table, we should have a salary information. In the second table, we can calculate a tax. Without the salary, we cannot able to calculate a tax. That is not possible, right? So these things, so we can able to implement. So within this particular, the task implementation. Now we wanted to stop this. How to stop it? Now, if you wanted to stop the same, like it's a like order. First, whom we need to stop? We need to stop the parent first. If I try to stop the children, observe this one. If I try to stop the children, see this. What it is telling? Root task is not suspended, right? So first we need to stop a parent. Now we stop the parent task. Now once we stop the parent task, then I have to run the child task. See this one? Now we ran the child task. Now both are in a suspended state. Now if you see the status show tasks, what you can see is I can see both, so child and parent, and then at the same time, so during this execution time, so both the parent child is completed, and then both are in a suspended state. See this? Both are in a suspended state, right? So like this, so we can create a task and then we can able to implement parent and child relationship here. Not only this, we can execute within a task, we can execute a procedure. So that is possible. Within a task, we can implement like a begin and end statement. We can handle the exceptions also, we can able to handle that. We will park it aside for the next discussions. When we are discussing with the procedures, we are going to discuss about that. Now one thing here, what we are doing, we are implementing a task only like based on the schedule, right? So it means once the task is like a schedule, we are giving only based on the minutes, right? So if I wanted to run a task, let's say for example, for example, I wanted to run a task based on my specific time. Every Monday I wanted to run. So I have given schedule time here for 1 minute, right? I don't wanted to give like this. I wanted to run every Monday, 10 a.m. I wanted to run, or monthly, every month, first week, Monday I wanted to execute, or week, every week I wanted to run 6 p.m. on every Friday, right? These kind of schedulings we can able to perform with the help of cron job syntax. So we can able to do it with the help of cron job syntax. You can able to see task history here, right? The same thing if you wanted to see the task history with the help of query, we can see this, the checking task history by using this command. You can able to see that. See this one. So information schema, task history. Now let's observe this. Just execute the command. Later we will come to the cron syntax. See this, the same information what you can able to see. See this one, we can able to see the task name. So what exactly is happening? These are the default tasks within a Snowflake. So you can see our tasks. What are the tasks? And then you can able to see that. So when it has been succeeded, so how much time it has executed, when it has been completed, like you can able to see the details here. This is one where we can able to see the information of the task in the task history. You can see that in the task history. Now let's come here. So I wanted to do it by using cron job syntax. This is the cron job syntax case. So here within a schedule, see this, it will be represented with stars, 5 stars. First one, from like right hand side to the left hand side, the first star it represents to the day of the week. You can give it as a 0, or you can give it 0 to 6 or 0 to 7. 0 and 7 both will represent for Sunday. So if you start with 1, 0 means it is Sunday, 1 is Monday, 1 is Monday, 6 is Saturday, 7 and 0 both will be represented to Sunday only. Now this is a day of a week. Second star related to month. If I give 1, it will consider as a first month. If I give 10, it will consider as a like 10th month. Next star it represents day of the month. So which day you have to run. Next it represents hour. Next it represents the minutes. This is day of the week. This is month. This is day of the month. This is hour. This is minute. Based on this, we can able to give the cron job syntax. For example, if I give like this is what is this one? Fifth, right? Fifth means Friday, right? This is 2, means nothing but February month. This is February 1st. This is hour, ninth hour. This is minute, right? Minute. So first minute it has to execute. So like that, for example, if I wanted to execute this cron syntax like this, see this one more thing. So here it will be minute, right? If I wanted to run, so every 15 minutes, see this one. This is how we will give it a 15 minutes, right? If I wanted to give like every 1 minute, so then star by 1 like this. This is related to every 1 minute, right? So based on the syntax, this syntax we can able to give. And then if I give this syntax like this, let me come and then give the syntax. See this one, I'm giving the syntax. So I will create task 1. I'm giving compute warehouse. See this, instead of schedule 1 minute, what I am specifying, so I need to specify this within a cron syntax using cron. This is the syntax for the cron syntax. And then you can specify the 1 minute means /1. This is related to star, right? Star related to minute, right? So 1 we have given. So what it will do, every 1 minute it is going to run, every 1 minute. Now let's execute this. The task will be created. So the task is created. If I wanted to schedule it, then we can bring this task to the schedule time. Then what will happen? Based on this cron syntax, then it is going to, you no need to specify, you no need to do any other additional configuration for this. Snowflake already will support cron syntax, you no need to worry about it. So directly you can use this cron, just you will give the command called using cron syntax, that's it. When you use this cron syntax, automatically it is going to be scheduled for specific 1 minute by using a cron syntax. So this is how, so we can able to schedule the task, we can manage the dependency, we can assign the task to the specific virtual warehouse. All these things can be possible within a task implementation. Okay, so this is about task. Now let's come to the questions. Yes guys, any questions here? So please practice this 1 or 2 times, then you will understand like behavior, how this is working, how the schedule is happening here. One task can have 2 parents. No, not possible. Every task it belongs to, it can be a parent, it can be a child. So that's the reason we are giving a dependency here. So one by one only we are executing. So if you observe here, see this, every task, one task, right? So this is a task. If you wanted to give 2 parents, that is not possible. That is a like restricted. You cannot. One parent task can have multiple child tasks. That is possible. When it is
Then, if we want to have two dependencies added to a task, how can we do that?
in that case, what you need to do is again see this. So what we have given here, task E, task D, task C, all is task B is a dependent, right? You can give the same way how we have given here. after task name. Just we will give after command, and then just you will give the task name. So you will create another child task. For example, this is child 1 task, right? The same way you will create child 2 task, and you will give the dependency of the same task. Again, the child 2, again I wanted to give the dependency on child D, then you have to give here alter the child 1, here child 2. Like that we can able to give. So it's a sequence. So which is first, which is next, based on that we need to specify.
Okay. Okay.
No, so you cannot do that, Sayed. So this resumption suspension, so we need to do it manually. So once it is triggered, automatically it is going to be executed, and so specific time only. So let's say if you wanted to suspend a task, yes, you can do that. But again, you need to create one task. Within the task, you need to give the other task suspended commands. That we can do that. But whatever the like a task it is there, that task we need to, the final task you need to suspend manually.
In projects, do we use a tasks or cron generally?
Cron syntax, yes, cron syntax we will use it. If we are not, if your project is not using any scheduling tool, then we are going to use this cron job syntax, Kalyani.
Okay.
Okay guys, if you don't have any, we will end up for today. See you tomorrow. Thank you all, thanks for your time.